So in the description, you can find the link to the website that has this particular document if you want to try these problems in advance. This is the review, and this is the first and second worksheets answers. I'm just going to go through one by one and try and give you some tips and some answers and kind of some help on organic chemistry. The first one, I have an alkene. Okay, so I have the double bond there, and I'm adding to it a hydrohalic acid. So what's going to happen is the H plus on this is going to form a bond with the double bond, pi bond from the alkene, and that hydrogen is either going to go on this carbon or this carbon. It's actually going to go on this one to form a carbocation there. And so the iodine that comes in after is going to bond to the middle carbon. So I'm going to end up with CH3CHI, CH3. That's an example of Markovnikov's rule, that the halogen will end up on the more populated carbon because that's a more stable carbocation intermediate. So that'll be what forms. Okay. So that's my compound A, which you can see here. So that says I take A and I add dimethyl sulfoxide and sodium hydroxide. So now we're looking at a substitution reaction. So we're looking at SN1 or SN2. The carbon is secondary, so it could be either one. And this is about as thin of a secondary carbon as you can get. There's nothing else besides those two carbons, which would probably tend us to a little more to SN2. We have a polar aprotic solvent, which would tend towards SN2. And we have a strong nucleophile and a good leaving group, so we're looking at SN2. But real simple, it's going to be substitution. This is going to displace that iodine, and I'm going to end up with a CH3, CHOH, CH3. I don't have to worry about 3D here because the methyl groups attached to the carbon are the same, so it's not a chiral center, and so there's no stereochemistry needs to kind of look at that. Okay? All right, so scrolling down from there. In the next one, we have a water molecule and sulfuric acid added to an alkene. So again, we're looking at addition reaction. And the water is going to add to the double bond. And so I'm going to end up with an alcohol. That's going to be CH3, CHOH. So we're going to look at isopropanol, CH3. Okay. Here I have a carboxylic acid and an alcohol. That's going to be a esterification. And we get confirmation of that from the water. This is going to bond to this. The OH and the H here are going to be the water. And the mechanism for that happening is much more complicated than that. But what we're going to basically end up here is we're going to take this component in blue, and then we're going to attach the oxygen component of this to complete our ester. There we go. So we would have methyl propanoate would be our compound. There we go. Let's stick that down there. Methyl propanoate. And class of compound would be an ester. Probably you're likely to see a follow-up, something about what in particular do esters do, and they're common for scents. They smell nice, and so you can use them in flavorings in food or perfumes or fragrances of different kinds. Okay? So, let's go ahead and flip this over. Take a look at Organic 2, which is also posted online. So if you want to pause and go ahead and try those real quick, you're welcome to. So here, we're looking at nitric acid and sulfuric acid and a benzene ring, which is indicative that we're going to add a nitro group. And so the NO2 plus from this, with the OH minus is the kind of the other part of this acid, the NO2 plus is going to add to this. Just offhand, I don't know at what juncture it's going to add, but if I look down here, I can see that there's an NH2 group added here, and so I'm going to add it at that same point as my final answer. So my product here is going to be the methyl group, the toluene, with the nitro group attached, so a nitrotoluene. And that's structure E. And it says I add something and a catalyst to E, becomes H, and then I add base to it, and I end up with this amine. So we're looking at a reduction reaction. So F and G are going to be something to reduce it, followed up by something to catalyze that, or something with that to catalyze that reaction. So let's okay. So the question is, let me kind of get that out of the way, and we can scroll all the way down. There we go. So this is this compound here, benzene ring CH3 NO2. Question is, what would I add to reduce it? And that's going to be some kind of reducing agent. The one that we're familiar with is tin, and then an acid to go with it. So hydrochloric works. I like to use sulfuric as my catalyst because it's a little more inert from the sulfate aspect. And then that's going to become H, and then later I add base to it. So the difference between H and my final structure, they're actually very similar. The only difference is that H is under an acidic environment, and amines under acidic environment will be protonated. And so I'm going to have an extra kind of H plus ion with a positive charge on that amine there. And that'll be the difference between H, that's H, and then my final structure. It will remove one of these hydrogen ions in an acid-base neutralization, and then I'll end up with the amine group in a neutral state. Okay? Cool. So more reactions posted, but there's a couple to kind of get you started on doing some review for organic.